Hey friends, in order to get a design that the town is happy with and that works well, you really need to rely on some of the principles that we're going to talk about in this video and on the engineering design process. So normally, we think that big and heavy things sink, and small and light things float, right? But have you ever thought about how something as big as a cruise ship can float, but something like a pair of sunglasses can sink? It's a little bit abstract, but it's all explained by something called buoyancy. But before we dive into buoyancy, we need to understand a topic called density, which is essentially how much something weighs relative to how big it is. Its formula is density equals mass divided by volume. And here are a couple prime examples. On one hand, we have a ping pong ball. On the other, a golf ball. They're about the same size, right? But which one is heavier and therefore more dense? We can ask ourselves the same question about a bowling ball versus a basketball. Same size, but one is definitely heavier and therefore more dense. Density has a massive amount to do with whether an object floats or sinks in whatever fluid it's in. So circling back to buoyancy, there's actually a famous scientist behind this concept by the name of Archimedes. And what happened with him is he sat down in his bathtub one day and had a big realization. He was so excited about this realization that he hopped out of his bathtub and ran to his lab before he even had the chance to put on clothes to go test some things out. You know we like to put some animations on the screen, but I don't think anyone wants to see one of that. Anyways, what was this big realization of his? This can get a little bit complex, but bear with me, friends. You know when you sit down in a bathtub and the water level rises? Well, his realization was that whatever object is immersed in a fluid, if that weighs more than the amount of water that was moved, the object sinks. If it's lighter than that, it floats. Like I said, I know that can be a little tricky, so here's a few quick demonstrations that should help us out. So remember our golf ball example? Let's take this cup of water, and before we dunk in our ball, notice the black line of the current water level. When we drop it in, the water puts a buoyant force on the golf ball that points in the upward direction. But in this case, the golf ball is heavier than that force, and the ball sinks. And notice where the water now goes up to. This is the area we want to focus on. We want to take this amount of water and think about how much that weighs. Again, since the golf ball is heavier or more dense than that amount of water, it sinks. Here is the exact same experiment, but with the tennis ball. When we drop it in, the water level rises dramatically, but this time the ball floats. The new water level is a little bit hard to see, so hopefully this helps spot it. In this case, the tennis ball is much lighter and less dense than the amount of water it displaced, and its weight is less than the amount of the buoyant force put on it in the upward direction. Therefore, it floats. So we really hope those illustrations help, friends. And let's circle back to our cruise ship example. Can you pause this video and try to think of an explanation for how on earth a big, massive cruise ship can float on water? And here's a quick hint while you're brainstorming. What's on the inside of cruise ships? Are they one giant piece of metal, or is it a little different on the inside? So that's right. Remember everyone, water is very heavy. Try picking up a couple gallons of it. And although cruise ships are heavy, for the most part, they're hollow on the inside. Sure, there's people and floors, but it's relatively light compared to the water that surrounds it. And how does all this matter to your project, friends? Well, if you can take what you learned in this video about density and buoyancy and couple that with a popular boat design, which we'll show you some more of in the next video, you're going to end up with a vessel that you're really proud of and that makes Sticksville happy. So we hope you're excited, everyone. We'll see you in the next how-to video where we're going to walk through some tutorials about how to build your own boat. In the meantime, if you want a tricky question to wrestle with, why do you think balloons float? What's inside balloons, and is it lighter or heavier, aka more dense or less dense, than air? Think about it.